Hello. So today I am going to solve this problem. This is Codeforces round 832 div 2 C problem. So here is the problem. That problem name is swap game. So here first of all I am taking the input what it needs to do. So it is given the time t, an integer n, and an array of size m should be taken as an input. So I am now, without thinking anything, I am now taking the simple input what the question is. So my input part is completed. Now I have to check for what I have to do with this array. So Alice and Bob are playing a game on an array A. So I have taken input that array n positive integers. Alice and Bob make alternating moves with Alice going fast. Okay, so we have to. So these two friends are playing a game. In his turn, the player makes the following move. Okay, so for any move, if a1 equals to 0, a1 means that element. So if a1 equals to 0 at any point, that means the player has loses the game. Otherwise, player chooses some index 2 to n. That means then player decreases the value of a1 by 1 and swaps a1 with AI. Okay. So question is understandable and short enough. So suppose I have an array 2, 3, 4, 5. So what can I do that? I have to decrease 2. I have to decrease 2. So it will be 1, 3, 4, 5. Then I have to swap 1 with these 3 elements. So suppose I am swapping with 3. So my array will be 4, 5. Suppose I am Alice. So I am going to give this array to Bob. Okay, so in this manner is somehow that Bob's gets 0 at its first index. That means Bob has loses the game. Okay. So I am checking with that if Alice is winning or not. That means I I have to keep the answer in this manner, that who will win the game, Alice or Bob. So I am checking if Alice is going to win or not. So suppose B is Bob and A for Alice. So if B loses, that means Alice wins. So when B loses, that means if B has the array something like this 1 and other thing 1 as his first index and any other, suppose any other random numbers. Okay, these are random numbers. So that means Bob has to reduce 1 with 0. That means Bob has loses. That means Alice won in this situation. So Bob has loses. That means Alice contains any number with random and have a greater value with 1 in the first index, and other elements will be 1 plus random. That means what I am trying to say, that if Alice has his first index number is greater than 1 and Alice contains 1 uh, this is others elements. That means what? That allies reduces this number to anything. Suppose it is 2, suppose it is 3. So allies can reduce it to 2, and what allies do, that allies will fetch that 1 to the first index to defeat Bob. That means if Bob has 1 at its first index, that means Bob cannot, the Bob will definitely make 1 to 0, and Bob will loses and allies win again. So everybody wants to keep 1 at its first index, and give the array to the different person. So allies will do that, and what Bob remains in this case. So in this case, I am writing down the case where allies will win. Okay, in this case, allies will win. So I am now going one step backward. That if allies have that number, so what Bob contains at that time? So if allies has one, so okay, so Bob will contain then. Bob will contain a number that is 2, right? If Bob contain 2, that means where from 1 came. That means previously Bob reduces it to 1 and swapping with the rightwards element. Okay, so this one came from this 2. So what will be that elements? If they are present any 1, what will Bob do? Bob will fetch that 1 to defeat A. So that means there does not remain any ones, right? Greater than 1 element and random. Any number, suppose here, in case of here 544. So what I am meaning random? Random means left element. So it will be good to write left elements. It is understandable. So I am sorting down with any. Okay, left elements. Okay, that the elements which are lefts. Okay, so if Bob has 2, that means Bob reduces it to 1, and then allies will do that. Allies will fetching that 1 to uh, to its first index and give it to Bob. That's how Bob loses and allies win. So this is the conditions where Bob, allies wins. Okay, or allies loses. So in this case, before this case, what will be there, that if Bob has 2, that means what? Where does the 2 comes? That means allies have swaps anything that is in this case, uh, allies has fetches 2 from here and swaps with the first index and give it to Bob, right? So here I have 2 and other left elements. So what does this contains? So this will contains definitely greater than 1. If this will be greater than 1, that means if this is 2, what happens, that it will reduces to 1? No, it will be greater than 2 as well, because if it is suppose it is 2, that means allies have to reduce it to 1 and give it to this, and then what Bob does, that Bob will do, that Bob will fetch that 1 to its first index and defeat allies. Okay, so that allies cannot let that happen. Okay, so allies must have greater than element here. That means here it is 3. That means Bob has no option to take any one from here. Okay, so these things goes on. So that means what? That if allies, if some elements mm, in the right words is uh, less than the first element of allies, that means allies will win. Okay, so what I am trying to say, that it is an observation that suppose these are left elements, and if any of the left elements uh, is less than the first index element, if there are any elements present, then allies will definitely win. So I'm writing down the conditions here, that suppose my first index will be first index element. So I'm writing down with x is my first element, so it will be a of 0. So if uh, if any elements is greater than, if a of I less than x, if any element is less than x, that means, okay, if any element is less than x, then what will happen, that then allies will win the game. Okay, so I am bull result equals to false. That first of all I am taking that allies will not win. In if this case happens, that means allies will definitely win the game. And now, okay, so if result is true, that means allies won the game. So I have to return allies. So otherwise, what will happen, that otherwise Bob will win. Okay, I'm commenting out this, and I'm checking if it is working or not. So okay, Bob LSLS, the sample test cases has passed. Now let's check. My one is code 3. Okay. Okay, it is accepted.